Welcome back, everybody. Another video series here at Blue Glow Electronics. I made a Facebook post the other day that said, hey, I may be looking at a Scott receiver, and it was actually this unit here, which was the 222D, if you can see that turned upside down. And kind of what I posted was, hey, I've got a couple of these things laying around here. Thought I might dive in and restore one or two of them. So let's see what all we got going on. The first thing I was going to call out was that I've got a couple different models here. So this is a 222D model, and this is a, if you can see right here, it's a little tough, but it's a 222C. And so I posted that online the other day and said, hey, I might restore a 222D and 222C, and one of the responses I got back was, well, what's the difference between these two? And I responded back basically with, good question, we'll figure it out as we go. But as I get to looking at it, there's a good bit of differences here. One, on the 222C, if you'll notice here, you've got this series of 4 buttons across the top, and then you've got 4 knobs here. So these top two are basically left channel and right channel treble, and left channel and right channel bass. And in the 222D over here, you'll notice they've ganged those up. So you have more buttons across the top, but you have less knobs here because they've basically doubled these knobs up and ganged them. The fronts and the left would be in the front, and the right in the let's see, left in the back and the right in the front. The few other noticeable differences I'm seeing, quite a few. On the D here, it's got a different, newer style knob, and these use the little brass caps that go on them, as you can see right here. We're missing some. I'm missing 1, 2, 3, 4 of the brass caps out of the 6 knobs. The other thing I've noticed is this got a pretty heavy-duty, what they call picture frame. It's still aluminum, but it's got some thickness to it right here. It's kind of solid on the front. And the 222C has a similar kind of gold anodized aluminum faceplate, but man, they are micro thin. You can see here it's only that thick, whereas this thing is a big old chunk. So that's another visible difference I'm seeing here on the front. Slight difference in the coloring too. The tan colored switches and the light champagne color here. The dark brown switches and the darker champagne color here. And the knobs are very different on the 222C here. As you can see, these really don't have the little snap-on brass caps. They're just gold-plated edges here on the edge of these things. And then when you get inside of them, I'm seeing even more differences. Quite a significant difference in the actual circuit layout. The components, if you'll notice the 4 tubes here, the 47199s are up here more in the middle on this one. They're all the way here at the very back on this one. You've got a dual set of capacitors here on this one, whereas on this one you got one here on the front and one way back here on the back. You can see the bottom of the BG024 8-pin octal socket here. This one's kind of back here behind 4 different bias, looks like settings, whereas this one only has 2 bias settings I'm seeing. A lot of the coupling capacitors in here I see are the same value. They're the 0.1 microfarad, 400 working volts DC. But significant differences here in the overall circuitry, the layout, the number of components. And we'll flip them over. It may even be some differences in the number of tubes as well. But thought I'd get you going here and show you. What I plan to do is I'm going to break this thing up into multiple sections. I've been getting some feedback that some of my videos are great, but they're really long, an hour plus. I'm going to try to start keeping this stuff to maybe 30 minutes, and if it takes more than 30 minutes to cover a topic, I'll just have 2 or 3 videos. So kind of what I've got planned here is, I thought while I'm going through this, why don't I just do both of these units at the same time and make the video. So maybe it's one prep unit, one prep video where we get ourselves organized, get some parts ordered and whatnot, and we're doing that today. Kind of explain a little bit about what we're planning to do and the approach and theory behind it. And then what we'll do is maybe I'll make 2 follow-on videos. Number 2 would be a restoration of this unit, and number 3 could be a restoration of this unit. Let me show you one other thing. Alright, sorry about that. So as you can see here, I've got a third unit. This is a 222C, just like this one. But let me show you why I may or may not restore this one. I've kind of got it kicking around the back of my head. But if you remember, I talked about how thin these corners were on these things. Well, that's what happened with this one. I actually bought this one off of eBay maybe a year or a year and a half ago as a fully working unit. The guy literally dropped it into a great big box and put some newspaper around it, like rolled up newspaper pads. Didn't wrap it in bubble wrap, didn't make sure it was secure inside the packing. When I grabbed the box, you could just shake it around. As you can see, some pretty major damage was done to that front corner plate. You can see the capacitor here was hit hard enough to break the little phononic mount below it or whatnot. So it'll depend on how these two go as to whether I do the third one. I thought about it. This third one, even with the bent faceplate there, I could bend it back a little bit. It would still make a great unit for somebody's garage or something, where it's not their primary listening station and it's not sitting in their beautiful living room or whatnot. So we may take a stab at the third one here while we're at it as well. But I'm going to put this one back up for now. Hey, in worst case, if need be, I could always, use this one as for parts only. Interestingly, when I filed a claim with eBay, or the buyer, basically about the poor shipping, I can't remember exactly what I paid, but anyway, at the end of the day, they ended up refunding most of my money, so I only have about $40 in this unit. The knobs alone on the front of it would be worth $40. So maybe we keep it as a parts unit, maybe we restore it and make it a functional unit. Okay, this 222D here also came with a nice metal cabinet, wood grain metal cabinet that's in really great shape. So I'll end up using that on the 222D. But let me walk you over here and show you something else. Kind of hidden down here on a shelf I have. There's a nice wooden cabinet for a Scott. Little secret, the unit that it's kind of hard to see in here. Lots of, not much light back here, but the unit that's in that is a solid state unit. I literally picked the solid state unit up at a flea market for, I think it was 10 or 15 bucks. The guy said, hey, the solid state unit didn't work, had some issues, and I said, hey, you know what, I'm willing to take a risk on it. But what I was really saying was, I need that wooden cabinet really bad, and I'm going to throw the solid state unit inside of it away anyway, or throw it down in that junk pile, along with a few hundred other solid state units I've got stashed away. But it's just one of those things that I knew when I bought it that wooden case would fit on one of these, just from previous experience. Another thing I wanted to mention, I was doing a little bit of research on this 222D and what the differences between it and the C were. And one of the things I found was that with the D, I found this just by Googling and reading some articles out there on a few different websites. But just reading on a few different websites, I found that even within the D, there are a bunch of variations in the circuit. So apparently there's like D models that have this older looking face, but the newer circuitry, and some crazy mixtures going on. So it's not as clean as like, the C here and the D here, and apparently there's variations even within those. I'm going to flip these radios over. Let's take a look at the top of them. I thought there's a few interesting things here. First off, the tube complement, and these are all either worn off or maybe it was never marked. I'm not sure on the 222C. But the first 4 tubes here on the front are 12AX7s. Then you have 2 7199 tubes, and if you'll remember, the 7199s were a really popular tube used in the Dynaco ST70s. But they're kind of a rare tube these days. They're not impossible to find, but they're not cheap. They're getting on up there at $40, $50 a piece now. Then you have 4 7189s, which is kind of a cousin tube to the EL84 or 6BQ5. The 7189 is a higher plate dissipation tube, a little bit hotter, and I'd recommend going back in here with either the 7189 or they make something called an EL84M, which is a little bit hotter EL84 that will work. And then finally back here you've got the GZ34 tube socket. I think we were talking about the 5AR4 or otherwise known as GZ34 when we last left off. If you can see here, this is the tube complement that came out of this unit. It's 4 12AX7s, certainly not matched by any brand. 2 7199 tubes here, as you can see. It has 4 7189s in it. 2 of them, if you'll notice here, have the distinctive Telefunken logo. And the others say IAC, which mean these are Mullards. And then it had a Raytheon US made GZ34 here. Anyway, this amp, if you'll notice, slightly different layout. GZ34, 4 of the 7189s. It then has 4 of the 12AX7s. And I haven't really looked at what these 4 tubes are that are in this one, but looks like made in Great Britain, so that's good. Mullard 12AX7s. And it has 2 additional tubes that this other unit, see the 6U8s instead of the 7199 tubes, which I thought was quite interesting right here. So that should make a difference. So one of the things could be that the 7199s were getting scarce and they moved to a more common tube here. Give you a little perspective. You guys know I'm a tube collector. Well, this is my 7199 bin. And as you can see here, I've got 2 sleeves of brand new GE 7199s and a sleeve of Raytheons. I've got 2 Sylvanias down in here. So what's that, about 17 7199s total that I have in my collection. This is my 6U8 bin, and each of these bags here has about 50 to 60 in it. I don't know. The stack goes on and on and on and on. My guess is there's somewhere between 7, maybe 6, 7, 800 6U8s in here. So yeah, I'm kind of glad they switched over and moved away from the 7199s because I've certainly got a whole lot more of these than I do the others. Okay, up next what we're going to do is start getting our parts list together for what we're going to do to restore these things. A couple things I'm going to do. First off, this capacitor right here, I'm going to figure out what it is. And I did a little prep work here. This is a 20-20-20-20 all at 450 volts. So basically there's 4 sections inside of that, 4 capacitors inside of one per se, all 20 microfarads in size each, and all of them 450 volts. This one here is, you can barely see here on the side, but it's 75, 75, 75, 75. So 4 sections at 75 microfarads each and 75 volts on each of those. This one's a little harder to read, but I'll tell you what's in it. There's actually 2 different sizes. There are 2 20 microfarad sections at 450 volts, and there are 2 25 microfarad sections at 25 volts each. And if you can see here on the top of my paper, I basically wrote all that down. 120, 20, 20, 20 at 450, 175, 75, 75, 75 at 75, one 2020 at 450 that also has a 2525 at 25 section. And we're going to do the same thing over here on this one. I can tell you pretty much the same game going on here. The only difference is this one capacitor right here. This one's the 2020 450, except for instead of 450 it's at 475 volts. This one, instead of the 75 is actually 100 at 75 volts. And then this one was the identical to the other 2020 at 450 and 2525. And as you can see here on this paper, I've written that down. So really the difference between the two is slight voltage on the top one, 475 versus 450. And the 75 versus the 100. Let's flip them over and I'll show you some more. Okay, we got the two units flipped upside down again, and what I've done at this point is I've basically gone through and counted all the coupling capacitors. You can see here they're all the old basically wax paper style capacitors. But I went through and counted them. So these are 0.1 microfarad here, 400 volts. And I went through and counted them, and what I came up with, there are 10 0.1 microfarad 400 volt capacitors. There are 4.022 microfarad 400. There are 2.25 microfarad at 200 volts. There are 6.015s at 400 volts and 2.047 at 400 volts. I'll tell you, some of these are not standard values today, like this 0.015, but I think we can find a replacement or use something very close to it. In this unit, I found a lot of them on the top here, and I also found a lot of them in the C unit here, 222C. Down inside here, the back faceplate, there's two down in here. There's two way down inside here you can barely see. But across the front here, there's about 6 total. When you get over here to the 222D, there's really none down inside there. You've got a couple that stretch across right here. But what looks to be more complex circuit-wise here on this board, the rest of that complexity on this one that seems to be simpler is actually hid down here inside this faceplate board. But I did end up with, actually, believe it or not, on the one that looks simpler than the less complex one, I ended up with less stuff on the more complex one. We've got 10.1 microfarad 400 volts, 6.022 at 400 volts, 4 microfarad 250 volt electrolytics, and 150 volt 50 microfarad 75 volt polycap, which was right here. It's basically nothing more than a noise filter on the power supply. So let's talk about approaches. There's a couple different approaches we could take to this. One, we could take a shotgun approach where we replace every bit of this. And I am inclined, as the proprietor of this company, to replace all of the old paper and wax capacitors. If you'll notice these capacitors right here, see the big bulges right here, wax on them. You know why that is? It's because they've gotten hot at some point in time. And typically the reason they get hot is they're starting to break down inside and they're starting to build up heat. And you'll find that wax dripped all over the inside of the bottom of the panel that goes here as well. The other thing is, it's really hard to test these. You can use an ESR meter, equivalent series resistance, capacitance meter. But it's kind of hard to tell, you know, when they're breaking down, how much DC they're passing. It's easier to turn a unit on and actually measure on one side and see how much voltage you got, and then see what kind of voltages, DC voltage is making it through to the other side. But my personal opinion is I like to replace all of these. It's just good practice. A couple different schools of camp out there around it. One says no, leave these old vintage things in here. They have a better, better tone, better sound, whatnot. I use a variety of different capacitors when I replace one like this. A lot of that depends on whether it's my personal amp or whether I'm building it to sell. So a good example, if I was building this to sell, I'd probably put the yellow probably polypropylene caps in it because they don't cost much. They sound pretty good, and it'd let me maximize my return on investment. If I was going to keep this personally, I would put orange drops in here, or step up to some Russian paper and oils, maybe some sunny caps, aura caps, different things of that nature. You can get into $2, $3, $4, $5, $10, $12, $15 a piece on these things with high-end caps. But just some good old Sprague 715p orange drop caps in these values would probably run $1 a piece ish, maybe a little bit more. But it would give you some great sound quality out of this thing. It's a great balance in the middle. Similar story over here. I'd replace all these as well as these electrolytics. Probably replace this polycap with another one. Just so that I know going forward these things are going to last and that they've got caps in them. But these things were made in the early 60s, maybe even late 50s, and this stuff just starts, the dielectric in them starts to break down. They become questionable. They might work fine now, but a year from now, after you've sold it to a customer, they bring it back to you and say, hey, I've got these popping sounds, and I don't know why, my tubes are red plating. Well, one of the main causes of your output tubes red plating is you will have DC coming from the previous stage, high DC voltage, feeding into the cathode of the following stage, where you shouldn't have any DC. You should just be passing your AC signal along, and it'll cause these tubes to heat up and red plate. The other thing there's multiple camps on, and that's these old filter capacitors. Do you leave them alone? If you do, you better get your ESR meter out and test them all real good. But about half the time I find these things actually perform fairly well. You can do some reforming of them. You probably find a video out there on that, where you bring these things up really slow on a variac over a very methodical time frame and kind of reform the caps. That's one approach. Would be to leave them alone, test them, make sure they're good. Two, you could wholesale replace them. You could try to order new caps to match these values. I will tell you that some of these might be easy to find. Some of these will not be easy to find one-for-one match. So you could try that route. The third thing is you could leave these in place, and you could just put new capacitors underneath the board here. So put them kind of around. You could use some axial ones and lay them down, or you could use some radial ones and stand them up. A lot of that depends on how much space you've got underneath here to work with and whatnot. But all those are, good, valid routes to take. The one thing I would not do is put capacitors on the top where you could physically see them. That's a pet peeve of mine. If you're going to change them out and do anything, do it all underneath the chassis. These chassis are pretty tight, I'll tell you. To find room to reproduce these things all underneath this chassis, a little bit of a tight feet. So hopefully I can replace some wholesale. Hopefully some will be good. I won't have to replace them at all. And hopefully the ones I do have to replace, I can just mount some capacitors underneath the boards here and route wires or leads over to their respective space. So in order of restoration, I will do a couple things. We will check out the power supply caps and replace those as needed. We will replace all the coupling caps in this thing. We will go through one by one as much as we can, and we will check all the resistors in these things, because these old carbon composite resistors tend to drift values pretty significantly. And when those are the, like I'll give you an example, these resistors right here are what are biasing the output tubes. If they drift off value significantly, all of a sudden your output tubes are off bias and not operating within parameters. They either don't sound great, they're producing more harmonic distortion than needed, they're rolling off on the bottom end or top end where they shouldn't be, or they're not producing as much power. Or worse, they could just be completely being overran with, say, plate current or cathode current, and they could be overheating and red plating. So we'll check all the resistors out, replace those as needed. I like to leave as much of the old carbon capacitors in place as I can. So these things have great sound to them. Then some of the newer, metal film and whatnot can sometimes have a little, bright sound to them, or so I've been told. Third on the list, we will go through and clean all the pots, deoxit all the pots real good. I'll give a good visual look over, make sure there's nothing been changed circuit-wise, and that, no wires are touching anywhere. We don't have transformer wires corroded to the chassis or whatnot. So we'll clean all the pots, all the switches really well. We will we'll clean all the connections on the back, as you've seen me do before, using a Dremel and a wire brush tool. We'll do that. We'll test all the tubes that we've got for these things. We'll make sure we put good matched pairs here in the output stages. We'll make sure on the input stages here that that these tubes have good matched sides to them as we're going through all this. Alright, so kind of explain the general approach of what I plan to do, how to get these things going. I will tell you that I need to order some capacitors. I'm going to start by testing these with an ESR meter. Hang on one second. Like I said, I'll hook all these up to an ESR meter. If you don't have one, these Peak Atlas are a really fun one. I like it. But I'm just measuring one section of this cap, and if you'll notice here, it's 23 microfarad at 0.96 ohms of ESR. That's a really low ESR value, so that capacitor is really good from a internal resistance standpoint. It means it won't heat up, it won't produce heat, it won't internally, which means it won't break down as much. It means it holds a better ripple current. And if you'll notice, the value was fairly within spec. It was 23. Sometimes you'll go to test one of these, and I'll show you here. You'll end up with a signal that'll tell you something to the effect of capacitance not measured, but the ESR is very high. And that might be because there's a resistor in line between these, and you may have to disconnect some things from that connection right there to actually be able to test it. But I'll go through and I'll test these things out really well, figure out what I need to order for the top here. But more so, I just don't have that many. If you're looking here, it's 20.1 microfarad, 400 volts. I probably have 20.1 microfarads. I don't know that I have 20 of the same type. So I think I'm going to go orange drops on these things. It's a good middle of the road approach. They sound really great. I like the 715Ps over the 716Ps. 716Ps are built on a pressed core inside versus the 715Ps, which are built on a cylindrical core on the inside. And there's some beliefs out there that the 715Ps are better and will last longer. So and they're cheaper, so why not go that route? So I'm going to order orange drops for all this stuff here at the bottom. Probably take a week or so to get them in, but you won't know it. And I'll just crank up the video another day, and it'll look just like a continuation of this. But in the meantime, in between this, I've got a preamp that a friend up the road in Raleigh sent me, and he started on the project a while back, and he never finished it. And I think I'm going to finish it up for him and get that done. So I'll try to make a video of that in between what we've got going on. I'm going to go ahead and wrap this up as part one of the Scott 222D, 222C restoration project. We'll get all this stuff ordered. By the way, I am going to order the stuff for that other amp, so it's really 30 of these things I need. We'll be back around for volume 2 of this here in 2 or 3 weeks. Thanks for watching, everybody. Thanks for all the feedback. Hope people continue to get value out of these videos. My goal is 1 a week. Can't promise I'll make that, but if I do, that'll get me in the 50 or so videos a year. Thanks for watching, everybody, and continue to throw me feedback out there. It really helps me in a lot of ways. Thanks again.